Hey everyone, thank you for watching our presentation. This is our semester project and topic is the Python programming language. My name is Shen and my partner Jackson worked with me on this. I will be go over to the intro history and a quick tutorial. Then Jackson will take over the show and the basic function and the whole example program. Alright, let's jump in. So the idea behind this project is pretty straightforward. We had to pick the programming language, learn it deeply, and basically understand why it works the way it does. And we chose the Python because honestly, it is one of the easiest language to read and write. It is also used everywhere right now, like the AI, data science, web development. So for our medium program, we keep things simple. We just write a few small examples to show like Python basic syntax, like a quick print statement, a bubble sort, and nothing big, just enough to demonstrate how Python handles functions, loops, and the basic logic. And the goal of our report is basically to explain what Python is and where it comes from and how where it fits the evaluation criteria we learn in class, like readability and writability. So Python was created by Guido van Rossum back in 1989 when he was working at a CWI in the Netherlands. And his main goal was to make a language that didn't feel painful to write. He wanted something more readable than C and more flexible than the ABC language he had worked on before. So in 1991, Python 1.0 came out, and it already has things like dynamic typing and exception handling. Basically, Python started off as a language that cared a lot about the readabilities and that philosophies never changed. After that, Python just kept growing. Python 2.0 came out in 2000 and added garbage collection, Unicode support, and list complications. Then Python 3.0 arrived in 2008, and that was a big deal because it wasn't backward compatible. A lot of people complained at the time, but it cleaned up and threw off the old design issues, so it paid off the later. Our interesting thing is how Python spread worldwide in earlier 2010 centuries, especially in China. Terms of the education centers start selling like a Python class to parents, and they push it kid-friendly language. Was the earlier than C++ or Java. So far a while, the Python's jobs market was the most education and the training, but of course that's changed pretty fast. Uh, the big turning point was the AI boom when libraries like TensorFlow, PyTorch, and Scikit came out. Python suddenly became the language for machine learning and data science that completely changed the Python's Python's reputation. It went from the beginner easy language to beginner mentors use the AI startup searches labs, big companies pretty like much everywhere today. Compares like Google, Meta, Netflix, NASA, they all use the Python, whatever it was the website development automation, uh, automation, science computing, or deep learning, Python is involved in somewhere, and you can see it on every job from to, and Python is always one of the most in demand skills. So there's the basic idea of how you can write the Python code and what the simple program look like. This is just meant to get you fit with. It's nothing too advanced. Jackson will just take all of this allowed function and go into the actual language functions like Python's paradise, data types, control flow, and object-oriented design. And he will show something of the example program we write for the project. There are a bunch of different ways you can write and run Python. The simplest one is the idle, which comes with the Python, but most people today just use the VS Code or Python, but because they are more powerful, and like for me, I really like use the VS Code because you can do everything much easier than before. I mean the traditional way. And if you are doing like AI or data science, you will probably think Jupyter Notebook. It lets you run code one piece and a time, since the output right way, which is super convenient. Even the built-in Python interpreter is nice if you just want to test things small idea. So the environment is the really flexible. Beginner and advanced user can both work comfortable. Even with a small example, Python's main functions really stand out. It's dynamically typed, so you don't have to worry about the declaring variable types. It use indentation instead of braces, which forces everyone to write clean code, and it comes with like a powerful built-in data structures like a list, dictionary, tuples, and sets. Python also has a readable error handling. The whole tried and exact structure is simple and clean. All of these things together make Python one of those languages that's easy to pick up, but still strong enough to serious project. Alright, let's wraps it up in the introduction, the history, and the shorter tutorial sections. I will hand it over to Jackson now, and he's going to walk through the core language functions, things like Python's paradigms, syntax, and operators, and error handling. And after that, he will demo the code example we built, include like bubble sort, linear search, and a few other things. So Jackson, just go ahead.
Hello there, I'm Jackson Lemons, and I'll be going over basic features and some coding examples for Python. To start with basic features, a common trend of Python's features is that it shares stuff many features in common with other languages, which helps improve learning Python or other languages and just going to and from various languages and Python. Python has three paradigms on how it tries to solve problems. First one is that it is object oriented. You can make objects based on classes, and these objects can access data types and functions within that class. This allows for plentiful code reuse by just having everything rely on a singular class or various different classes to help define stuff. Next one is procedural paradigm, where you can define functions that can contain commands to do tasks. This allows for more module style coding, as if something is used often, you can just do that, and it allows for simple coding. And next one is the functional paradigm, where coding is based on real-world mathematical functions. That this can help improve the understanding of how to debug code or how to code a solution into something. Python has quite a few data types, and so to go through them, strings are sequences of Unicode characters or simply things like words and such. Ints are basic whole numbers, floats are decimal numbers. Complexes are strange as they can involve imaginary numbers. Lists are sequences of any data type, as you can see, the example next to it shows an int, a string, and then a float, which sets it apart from quite a few other programming languages being able to do that. A tuple is like a list, but it's immutable once it's created and can't be changed. A range is a sequence of numbers that, depending on what input you give to the range, can vary on how the sequence goes, where it starts, where it ends, and how it increments or decrements. A dictionary is a collection of key and value pairs, so you can call a dictionary in a specific key to receive a certain value from it. A set is similar to a list, but cannot have repeating values in it. A frozen set is like an unchangeable set, being equivalent of like a set and a tuple combined. A Boolean is either true or false. Bytes, byte arrays, and memory views allow for accessing bytes or memories of specific things, but is a bit complex, and none type works as a simple null value for anything. There's few different commands for trying to control the flow of Python code. If, elsif, and else allow for only doing code if a particular condition is met, usually being true or false. For and while repeats code until a condition is met, with for being usually a set amount of times, while is until a condition becomes true. Break allows for immediately leaving a for or while loop, while continue allows going straight to the next iteration midway through. And define allows for creating blocks of code that are only performed when they are called by some other spot in the code. For some expressions that are in it, it has some things like mathematical operations that usually relate to the real world thing. There's addition, subtraction, multiplication, division, and then also quotients, remainders, and exponentials can be done via either double slashes, that symbol, or double asterisk. And on the other hand, there's also Boolean values where you can do less than, greater than, less than equal, or greater than and equal to, but also you can do and or not, and being true if a value to its left and right are both true, or being true if either value on its left and right is true, or not, being only true if the value next to it is false. For subprograms, Python uses define to show when a function started. It is then followed by a name, and then within the parentheses contains all the parameters that is given to the subprogram. Code is ran within it and can be called from elsewhere. As you can see on the example on the right, the bottom code prints example 10, and so it goes up, and in that code, the code multiplies that 10 by 3 and then returns it, which then prints 30 out onto the thing below. Objects are quite an important thing within Python, and so classes work as templates for objects. And as you can see on the code on the right, the underscore init underscore thing is used to initialize an object when it is first created, and self is used to refer to an object while within a class. So on the example on the right, what happens when the cat object is created, it is initialized where the name that is given is added to the object, and then at the bottom it can print that name for the object, showing an example where a data type in the class is defined and can be called per object, creating two different outputs. Exception handling in Python is done via the try and except commands, as they are used to catch errors. A try will run a block of code given to it like normal until an error occurs. If an error occurs, it will look for an except right afterwards with the error that it has. If an except is found, it will run code within the except and continue the program like normal. However, if it can't actually find something like that, then it will just eventually stop the program entirely. So this allows for finding errors like this without completely breaking the entire code. Next section will be code examples, where I have 3 code examples comparing C++ and Python, as almost anyone that should be watching this should have knowledge on how C++ works, so it will work as a good ground point to show major differences Python has, with notably how much simpler Python code is compared to C++. To start code examples, Hello World is the first sample we have here, and with Python on the right and C++ on left, on the Python one, you can tell that it is quite simple, being just a print hello world, and that it's capable of working. While with C++, there's a lot of extra things going on. It has to include I/O streams, so it can actually output to the console. And main is used to show the main code. It has to do the cout, so it can output to the console hello world, then followed by an end line, and then return 0. Next up, for an example, is the bubble sort algorithm. Well, there's a lot of text. I'll help point out notable differences. For C++, it has to include 3 different things, while Python includes nothing. Things for C++ being I/O stream, so it can output to console, vectors, so it can use that for the bubble sort, and algorithm, which allows it to swap 2 things that's used for swapping in the bubble sort. Well, Python just includes nothing. And for the main part of the code, a notable difference is that Python is capable of just outputting an array straight to the console, while with C++, it has to loop through the vector, so it can actually go thing by thing outputting stuff. Final example we have is linear search algorithm. This one is mainly just focused on the linear search algorithm itself to show a different thing compared to the rest instead of just repeating stuff over and over. This one is more to focus on the fact of just the size of the code. On Python, the linear search is just generally a lot less code or text overall is needed to do it. You can see in like defining the parameters in Python, you just put two values, and it just knows, since it auto does that, while not having to define every single thing like in C++. And generally, just code is smaller overall, allowing for easier comprehension to read the code and find problems. Thank you for listening to our presentation on Python. It's not hard to see why it's such a popular programming language due to just how easy it is to learn for beginners while still having enough depth to allow for more complex programs. So it just ends up being one of the best programming languages, just there simply is.